Step one, what am I going to do first? What's the very, very first thing I want to do here? Darius, go for it. Draw the line down. Good. I love your thinking. We'll get to the line. Take a look back at yesterday. What was step one?
Make everything into a fraction.
Make everything into a fraction. We've got 3 fractions, but we need 2x to be a fraction. So what can we put under the 2? A 1. Boom, boom, just like that. Now I've got 4 different denominators here, which complicates things a little bit. Hopefully not too bad. I've got 3, 4, 1, and 12. Who could tell me what's my LCD going to be? 12, right? 3 is a factor of 12. 4 is a factor of 12. 1 is a factor of 12. My LCD is 12. So I want all of my all of my terms to have a denominator of 12. Go ahead and make sure everyone's got 2 different colored highlighters in front of them from your supply box as well. Five over 3x, is that a variable term or a constant term? Variable. What about 1 over 4x? Variable, I heard someone say it, thank you. 2 over 1x, variable as well. And negative 7 over 12. There's my constant term. All right, we've got our highlighters. Let's come together, get that highlighted real quick. Now let's figure out what our missing multipliers are. Let's go term by term, starting here. My denominator is 3. Stay with me. I want my denominator to be 12. What can I multiply 3 by to get 12?
4.
Just 4? It's going to be a fraction, right? 4 over 4. Thank you. I've got 1 over 4. I want 4 to turn into 12. What can I multiply this one by? 3 over 3. I've got 2x over 1. I want my denominator 1 to be a 12. What can I multiply this one by? 12 over 12. And my denominator here is already 12. We'll leave that one alone. So let's see what this turns into. We're going to get 4 times 5. What would that give me? 20x over 12 plus 3x over 12 equals 20. That's not a 24, is it? (24x over 12 minus 7 over 12). All my terms are on the same level now. They're all out of 12. What can we do with all those 12s? Cross them out, right? 12, 12, 12, 12. They all go away. We're left with the equation 20x plus 3x equals 24x minus 7. Variable, variable, variable. Good morning, Nellie. Constant. Thank you. So re-highlight those new fractionless terms for me. And then, Darius, what are we going to draw through that equal sign? A line. We don't want to draw that line yet. I mean, technically we can. But really, we only want to draw that line once we start doing inverse operations and combining like terms, right? So, make sure you understand how we got to this point. What do you see that I need to do first? Combine like terms. Which like terms? 20x and 3x. When we add those together, what would we get? 23x, very nice, equals 24x minus 7. My two variable terms on the left have turned into one single variable term on the left. And I've got a variable term with a constant term on the right. You guys kind of see how we're mixing in all our previous lessons now? What can I do next? Well, I have two more yellow terms I want to combine, but they're across this kind of dividing line here. So if I want 24x to jump over that line, what would I have to do? Starts with the S. Subtract 24x, because the inverse of 24x is negative 24x. And we're going to do that on both sides. If I'm going too fast, let me know. What happens to our 24x's on the right? Cross them out. Good. All we're left with is negative 7 over there. And what's 23x minus 24x? Negative 1x. Now I've got one single variable term on the left, one single constant term on the right. Once we see that, it's time to divide every time. Unless our x is already by itself. But it's not here. What do we want to divide both sides by? Negative 1. The negative ones on the left cancel out. I'm left with x equals, what's negative 7 over negative 1? Just 7. The negative signs cancel out. 7 over 1 is just 7. Boom. There's my answer. What's that? One more. Halfway done. Because in the next example, we're going to learn a shortcut to uncomplicate things now that they're complicated. Take a look at that. Isn't it beautiful? I think it's beautiful. Sure. Questions I can answer on that example. All right, give me a quick show of thumbs. How we feeling about this? Thumbs up. It sounds good. It's making sense. Now that we've got review, we slept on it. Thumbs sideways. Guys, I'm talking. Thumbs sideways if it's still a little bit iffy. Thumbs down if you're completely lost. Whichever way. Okay, I see some thumbs sideways. Maybe the shortcut's not the best idea, but we're going to do it anyway. Let's take a look. Let's say we have 1 over 6x plus 6 over 9 equals 16 over 18x minus 3 over 2. How many terms do we have in this equation in total? We got 4 terms, right? 2 variable terms, 2 constant terms. How many different denominators do you see, though? 4. We've got 2, 6, 9, 18. Can Can anyone look at those four denominators and determine what my LCD is right away? 18. How do we know it's 18? That's right. I heard a couple things. 6, 9, and 2 are all factors of my largest denominator, 18. Remember yesterday we said if all the smallest denominators are each factors, meaning they go into evenly the largest denominator is my LCD. So I'm going to write over here my LCD is 18. All right, 6 times 3 is 18. 9 times 2 is 18. 2 times 9 is 18. 1 times 18 is obviously going to be 18. Again, just so we're clear, I've got a variable term, a constant term, a variable term, and a constant term. One of each on both sides. So, shortcut is not, we're not changing anything about our process. We're still doing all the steps. Well, we're missing one of the steps, but you'll see what I mean. Let's figure out what we need to multiply by, right? We want 18 on the bottom, and I got 6. What can I multiply 6 by to give me 18? 3. So we're going to hit that first term with a 3 over 3. What about this one? 6 over 9. What can I multiply 9 by to give me 18? There's my 2. Good. 2 over 2. Do we need to do anything with 16 over 18x? Nope. It's already what we need. And if my denominator is 2, what can I multiply 2 by to get 18? 9. 9 over 9. Here's where the shortcut's going to come in. So make sure you're all caught up on that. We're going to work all this out, and then what do we typically do after we work all these multiplications out? We cross out the denominators, right? Well, why are we writing this whole equation just to cross out all the denominators? I look at this and I know, okay, 3 times 6 is going to give me 18. 9 times 2 is going to give me 18. I've got an 18 there. 2 times 9 is going to give me 18. Everyone see what I mean by that? We see that we're going to have identical denominators. So let's just cross them out now. Just like that. Now we just have to focus on multiplying across the top. What's 3 times 1x going to be? 3x. Thank you. What's 6 times 2 going to be? 12. 16x is just 16x. And what's negative 3 times 9?
27.
Negative 27. Now we're ready to split it up and solve it out. So it's a shortcut in the sense that it saves us time in writing out that additional step. But again, you see we're doing the exact same thing. Just now that we're more comfortable with it, we can cut a few corners to make our lives easier. I'm going to re-highlight my 3x and my 16x in yellow. My now 12 and negative 27 in pink. Whatever colors you have work as well. Give you guys a few moments to highlight those, and then we'll get to solving. Who can see what I need to do now? I've got a variable and a constant, variable and a constant. Just like always, I want to bring my variable to the left, bring my constant to the right. So what can I do with this 16x? Subtract it from both sides. Minus 16x, minus 16x. Cross those out. What's 3x minus 16x going to give me? Perfect. Thank you, guys. Negative 13x. Got a new variable term. Same old two constant terms. Brought my yellow term to the left. What am I going to do with that plus 12 if I want to bring it over to the right? Subtract again. Minus 12, minus 12. Those 12s now go away. I'm going to bring this in a little bit. Negative 13x equals, what's my right side going to be? Negative 39. Awesome. Absolutely right. Now I've got one yellow term on the left, one pink term on the right. That means it's time to do what? Divide. By what? Negative 13. We're going to divide both sides. The 13s on the left cancel out, leaving me with x equals, I know my negative over a negative gives me a positive. Am I just going to leave it as 39 over 13? No? Why not? Can we simplify it? Yeah, how many times does 13 go into 39? 3, right? 13, 26, 39, 52, 65. Right, if we just add 13, we get x is equal to 3. Boom. So I know it's not a super crazy shortcut, but that's how much space we took up with that second one versus all this space we took up with the first one. Does save us this much room when we're going through it, right? Yeah. No, if you're comfortable without highlighting on the worksheet, you don't have to highlight on the worksheet. But again, I think it might have just been because we didn't have an example in the notes with like terms on the same side. That was my bad. But there was a whole lot of mistakes yesterday on not combining like terms. So now that we're aware that that's a possibility, just like in this first example here, keep that in mind. Be super, super careful with what terms you're going to subtract and what terms you're going to combine. All right? Final questions I can answer? Yes.